Welcome to another video. So in this video, we're going to talk about the law of cosines. We just finished talking about the law of sines, but there was two cases that the law of sines did not work for these oblique triangles, and they were cases 3 and 4. So law of cosines does. We'll talk about why it does. We'll talk about why law of sines doesn't work. I'll tell you exactly what law of cosines looks like and how to work with it. It is quite a bit more straightforward than law of sines because there are not two cases that can work like the side-side angle that we saw with law of sines. So what law of cosines does, working with these oblique triangles like we know it does, it will solve your triangle for you if you know two sides and the angle between them. So the sides are adjacent to the angle, or if you know all three sides of a triangle. It will solve the rest of it for you. So we're going to take a look first at this, what the law of cosines says, how to apply it to two sides with the angle between, why law of sines will not work for that, and then all three sides and why law of sines won't work for that. So here's what the law of cosines says. If you have a triangle and you don't know if it's a right triangle or not, what law of cosines really talks about is a way to compare in an equation two sides and an angle between them with another side. Here's how it looks. The law of cosines says a side squared is always equal to the other two sides squared and added, so the sum of the other two sides squared, minus twice the product of those sides and the cosine of the angle between them. Now that sounds like a lot. That is a lot. But I want you to notice a couple things about this. This is a side. This is the angle opposite that side. This is the angle between these two sides. So when you're setting this up, you look for an angle that you know. If you don't know an angle, you're solving for an angle. So you identify the angle you want to know, just like we've done every other time. Identify the angle you want to know or the angle that you have. And the side opposite is the one that you need to find. Why? Well, because this works for side, angle, side. This works for, you know, two sides and you're missing a third. So naturally you'd want to find that third side. Well, you need to know the angle between these two sides to do that. This side is found by knowing these two sides, boom, 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 and the angle between them, right there. That's exactly what that is talking about. You know two sides and angle between them, therefore you're able to find that side. Now what do you do after that? You find the angles, because you'll know all three sides. You can find the angles after that. Now, of course, what if we're not just looking for side C? What if we're looking for side A or B? So there's three kind of permutations of this, rearrangements that we can deal with. If you wanted to find side B, well then B squared would equal the sum of the squares of the other two sides minus twice the product of those sides and cosine of the angle between them. If you remember that, you don't have to remember the formulas as much. Just remember that this side and this angle are opposites, and the rest of the stuff are the sides that you already know. What if you're trying to find side A? Well, then A squared is going to be the sum of the other two sides squared minus twice the product of those sides and cosine of the angle between them. This is opposite that angle. These sides you would know. This is what the law of cosines says. One more thing I want to mention is that if you know all three sides, then you're solving for an angle. Because why would you want to solve for a side? You already know it. So this really only works in two cases. If you know two sides and an angle between. Why? Because that allows you to set up this with all the information. Law of sines would not do that. And we'll see that in our very first example. If you have all three sides, then we'll be solving these for our angles. Now, I'm going to give that to you right now as sort of an aside. So if you were to solve this for cosine C, cosine B, and cosine A, it would give you three different formulas. How? We're just going to subtract these two, and divide by this. Or you can think, add this, subtract your c squared, and divide by 2ab. Either way you go, you'll end up with a different equation. The other thing, the last thing, this is quite important. I want you to see what would happen if that angle was 90 degrees. Think about this. if that angle was 90 degrees, do you remember what cosine of 90 degrees is? Do you remember cosine of pi over 2? It's 0. If that's 90 degrees, this part is 0. This part is 0. Now think about this. If that's 90 degrees, what's the side opposite 90 degrees? It would be a hypotenuse. This would be a right triangle, and you would get a squared plus b squared equals the hypotenuse squared. If this angle was 90 degrees, cosine of that angle is 0, it zeroes the whole thing out. Pythagorean theorem is a special case of the law of cosines. If you have one of these angles 90 degrees, then you have Pythagorean theorem. What if this angle is 90 degrees? Well, then that would be the hypotenuse. If this is 90 degrees, this is 0, that's a hypotenuse. A squared plus c squared equals the hypotenuse squared. It works. It's just a special case. So I'm going to solve these for you. All I'm going to be doing is, honestly, I'm going to be adding this to both sides, subtracting c squared and dividing by 2ab. And so you could use this to find your angles. Of course, we plug all this in and then take cosine inverse of both sides to find a missing angle. This is typically the process we go through. So I'm going to explain to you so there's no surprises. If you have a side angle side, yes, you're using law of cosines. We're going to find out that law of sines will not work. You find the side you're missing first, and then you find another angle second. How do you do that? You use either this. If you have all three sides, then naturally you're going to be finding an angle, and you have to use one of these. So that's why I'm giving it to you. That's why we're going to practice it, just to make sure that we're seeing it. All right, let's take a look at an example. We got this triangle. We know two sides and one angle. Now, this is why it was so important to understand law of sines and the difference in law of cosines. Law of sines says you know two sides, like we do, and an angle, but in law of sines, the angle is not between those sides. Law of cosines it is, so which one is this? We have a side, then an angle, then a side. This is a law of cosines. It's two sides with an angle between. So in my head right now, I'm thinking, number one, this is not a right triangle. Do you remember that? Like if we the first thing we do when we look at it is think, is this a right triangle? It's not, or at least it's not telling me that it is. So I cannot use right triangle trigonometry. I'm looking at it and thinking, okay, let's categorize it. This looks like it's a law of cosines because there's a side, two sides and an angle that's not between them. Also, I'm looking, can I use anything outside of law of sines, law of cosines, trigonometry to solve for a missing side or angle? You cannot. Please do not use Pythagorean theorem. You're not sure if that's a right triangle or not. It's not. You cannot use Pythagorean theorem to solve for that side unless you are absolutely certain that you're dealing with the right triangle. We can't use interior angle sum. Those are the two things we normally want to do before trying our trigonometry type stuff is Pythagorean theorem, it won't work. Interior angle sum, it won't work because we don't have enough information. So we said right triangle, no, it's off the table. What's it fit better? Law of sines, law of cosines. Looks like law of cosines. I don't have anything else I can fill out. Let's start labeling this triangle now. So I'm going to call this side, there's angle A. And so this would be side A, lowercase a. Let's call this angle B. This would be lowercase b. I'm going to write that now just so that we can follow our formula. If you're more of a formula type person, it helps to label all of your sides and all of your angles so you can just plug it in. If not, if you're more of a concept person like I am, you don't really have to label a lot of this, just the things you're missing. And so this would be angle C, and of course the opposite side of that would be lowercase letter c. Now, because we already know that law of cosines is going to work, we can follow one of these formulas, but keep in mind what you need to do. There's no way to solve for an angle right now. You can't do it. You don't have enough information. If we tried, we would only know two sides. We'd only know one angle. So we can't find another one of these angles because we'd be missing too much. Also, notice why the law of sines does not work. Remember what law of sines does. It takes one completed proportion or fraction and sets it equal to kind of half of a completed fraction in a proportion. Notice that we don't have that. We don't have one complete fraction. We have an angle with a missing side. We have a missing angle with a side or a missing angle with a side. We'd have two pieces of information and we're asking for two more. You can't do it. You need to know three things in order to find a fourth thing with law of sines. we'd have an angle over a, oh man, that's not completed, a side over a, that's not completed, or a side over a, that's not completed. Law of sines fails because of that. That's why we had the side-side angle working for law of cosine, or law of sines, but side, angle side, the angles between them. This is where law of cosine shines, is because it works here. Law of sines doesn't. I hope you see that. I hope you see why it doesn't, because one of our fractions in our proportion would not be completed. We can't complete either of them, so it fails. So what do we do? Well, because you can't solve for an angle right now, notice if you tried to solve for, let's say, angle B, you would need to know A and C. We don't know A. We can't solve for that angle. If you want to solve for angle C, we'd need to know A and B. We don't know A, therefore you can't solve for the angle. So in order to solve for the angle, you need to know the sides that are next to it. That's what this is really saying. You need to know the sides that are next to that in order to solve for that particular angle. So our first step would be, let's solve for this side that's opposite the angle that I know. That's what this is going to let us do. So when you deal with law of cosines and you have sine angle side, you're solving for this side first. Now, if you're more formula oriented, you've labeled everything, then this is going to drive what formula you use. You look at this and go, I know my B, I know my C, I'm missing my side A, I'm missing this. You're going to use this one, and then you fill out all of your information from that formula. If you're more of a concept person, like I am, we write down the side that we're missing. We think this is basically like Pythagorean Theorem. It's just I have an angle between the two sides that I know. And so what I'm going to do is I'm going to say, okay, a squared is going to equal 3 squared plus 4 squared, the other two sides. It doesn't matter the order in which you put those, by the way. I know I might be out of order here. It doesn't matter. Addition's commutative and multiplication's commutative. It doesn't matter. What does matter is matching up this side with cosine of the angle opposite it. So I'm missing side, whatever it is, A. I have 3 squared plus 4 squared. Great. I'm going to subtract 2 times their product. And then cosine of the angle between them. If it's the angle between them, that angle is opposite the side you want to know. So this and this angle are always opposite in law of cosines. So this and this angle. So I'm going to put cosine of 30 degrees. I'm going to double check. Side I want to know equals sum of the other two sides squared. Great. I've squared the side I want to know. Minus 2 times their product. I've done that. And cosine of the angle between them, which is also the angle opposite the side we want to know because of the side angle side that we've come up with. And now we're just going to do all the work. So this gives us 25 minus 24 cosine 30 degrees. Begging, do not subtract those. It's very common if you're going really fast or you're stressed out about a test to accidentally subtract those. That's not what we're doing. This has a product with it, and order of operations says you do multiplication before you do addition subtraction, so you need to know that first. So cosine of 30 degrees, that's like square root 3 over 2. For us, we can use our calculator and approximate this. But if you're going to approximate it, take a square root of both sides and put the square root on the whole thing. Put this in your calculator. What not to do. Don't figure this out, then round it, then take square root of a rounded number because you're going to be compounding your error. So do all the math first. Let your calculator do the work for you. A equals this thing. This is the exact amount. Like this is exactly how long that side is with that angle and these other two sides. That's great. But it's not as usable as we like. So we'll approximate it. And we get approximately 2.05 units, whatever that is. So we've used law of cosines. We found out our missing side. Now what? Well, there's only one more thing we have to find, and then we'll use interior angle sum to find the last angle. We have to find an angle. How we do this is up to you. Whether you want to use law of cosines or whether you want to use law of sines. Oh man, check this out. The one piece of information that was missing for us to use law of sines was that side. If we had known that side at the beginning, we would have taken sine of an angle over its known opposite equals sine of an angle over its known opposite. That would have caused a law of sines situation. We could have solved very easily for that angle. Yeah, we would have had two cases. That's true. We don't have that here. We won't have that for law of cosines. But at this point, you could certainly do law of sines right now. You could do sine of 30 degrees over 2.05 equals sine of c over 3. And you could figure out angle C. You could do the same thing for angle B. That's very, very possible. On the other hand, if you don't like that, you don't want to deal with the law of sines again, you could use the law of cosines to find a missing angle. We just have to really remember that when we're solving for an angle, you're really using these formulas. So if we want to solve for, let's say, angle C, we need to use cosine of angle C. And what that does is that takes the sides that are adjacent to angle C, the opposite side, and divides them by the product of the sides adjacent. So this angle is between those two sides that you know. Also notice one other thing. Whether you use law of sines or whether you use law of cosines, we can't avoid using this approximation in our math. We could if we wanted to use this whole thing. It gets really messy, but typically we are using an approximation here. So I'm going to use the law of cosines. I'm going to find angle C. So in my head I'm thinking, if I want to find angle C, it's going to use the adjacent sides and subtract the opposite sides squared and divide by the product of 2 times the product of the adjacent sides. So cosine of C, here's angle C. This is what I'm finding. I'm going to maybe make a reference here. I'm going to square my sides adjacent, subtract my side opposite squared, and divide by the product of 2 times my adjacent sides. That's about it. So this is going to give us cosine of C. If we want to find what C is, we need to take cosine inverse of both sides. Me personally, I would plug all of this in at one time in my calculator. I would say that C is cosine inverse of all of this stuff. And I would do it just like that. I would do cosine inverse, put a parentheses, put a large parentheses for my numerator here and here. Plug in my 2.05 squared plus 4 squared minus 3 squared, end parentheses, fraction or divide, and then put in 2 in parentheses here as well. 2 times 2.05 times 4. That way I'm not doing things like, oh, round this and write it down, then add this and subtract 9 and then write it down, and then divide by this written down and rounded, because you just compound a lot of errors that way. So it's best to not round as much as you can until the very, very last step. And we get that C is approximately 46.9 degrees. Now, if that's 46.9 degrees, how do you do the rest of it? There's, again, 2 options. Could you use interior angle sum to figure out angle B? Absolutely. Yeah, that's totally fine. You can do that. Why? Well, because subtraction doesn't compound the error that you get if you round to the same number. So option 2 is you use the law of cosines again to solve for angle B. So you'd get B equals cosine inverse of all this stuff. You'd square 2.05, you'd square 3, you'd add them, you'd subtract 16, divide by 2 times 2.05 times 3, take cosine inverse of that, and it's going to give you exactly what angle B is. That is actually a great way to check your work. So remember, interior angle sum has to add to 180. If you use interior angle sum and you find this out, what if you were mistaken here? If you were, it wouldn't show up. If you use the law of cosines again to solve for angle B, and then you add these things, if you've rounded to the same decimal, it should add up to exactly 180 degrees. So that is a definite good way to check your work. I'm going to just kind of be lazy a little bit, and I'm going to use the interior angle sum. So 180 degrees minus 30 minus 46.9 is going to give us angle B. And we get about 103.1. Again, if you really wanted to be sure, you would have to set this up again, law of cosines with angle B. You'd have angle, well, I guess we could write it out. Angle B would be, well, cosine inverse. You'd have to take cosine inverse of both sides. Let's see. the sides adjacent to angle B squared, so 2.05 and 3 squared, minus the side opposite squared, that's what this is telling you here, divided by 2 times the sides adjacent. So these same two numbers. That's precisely what we had down there. Remember that 3 was opposite C, just like 4 is opposite B. And this is going to equal, if you round to the same decimal place, exactly what that is, 103.1 degrees. I hope that makes sense. I hope you're seeing the ideas going through it. One other thing is, if you were to use law of sines, you could certainly do it here. But because that's rounded, and you have to use that in a sine inverse, it's going to really compound a lot of error. Also, you'll have to deal with the two solutions idea there, and only one of them is going to work. So it can be quite challenging. So my encouragement would be use the law of cosines. There's not two options here. You just get that one. And then use either law of cosines again to find the different angle, or interior angle sum if you're sure that you got that right. Interior angle sum would not check your work though, where another law of cosines would. So I hope that makes sense. It's a little bit more straightforward than law of sines. Let's go ahead, we'll do a couple more examples and end with an application. Okay, so we have another example. We've got a triangle. We're not sure if it's a right triangle. We know only that we know it's 3 sides. Well, Pythagorean Theorem wouldn't help us anyway. We already know the 3 sides. And it turns out this is not a right triangle. It's something where we only have to find our angles. Now, how should you go about finding your angles? You have a few options here on how you want to do this. Number one, the side, knowing all 3 sides is perfect for law of cosines. Notice why law of sines wouldn't work. We have no angle, and so we would not be able to complete one of those fractions. With law of sines, you have to have a complete fraction equal to half of a completed fraction. That's a proportion for you where you can solve for one part. Remember, 3 pieces to find a fourth. For law of sines, you need to know either 2 sides and 1 angle, or 2 angles and 1 side, and that's not what we have here. So we have all 3 sides. Law of cosines will do that for us. But we're only finding, of course, our angles. So this doesn't really work because this is how we find our sides. We need to know how to find our angles. So here's where the options come in. While you have to use law of cosines the first time, once you find that angle, you could use law of sines. Now, should you? I'm going to say probably not most of the time. And for a couple reasons, when we get there, I'll explain to you a little bit more. But because the law of sines is going to compound by a sine inverse some of these errors, cosine can do that as well, but you don't have to use that in cosine. To use law of sines, you'd be using a rounded side, and the sine inverse is going to make a large difference numerically if you're using a rounded number. Now, if you're not, then it would be fine. The second reason, and probably the most important, is that with law of sines, you get 2 answers for your angle. Do you remember that? Like, you have this theta and 180 minus theta. You'd at least have to check this. Only one of them is going to work in law of cosines. So there's only one equation that will be true here. There's not an ambiguous case, but you would have to go through the process to see which one is which, and that can be kind of annoying. So could you? Yes. Should you? It depends. Now, I said at the beginning, like, yeah, I would normally use law of sines, but there's a trick I'll show you that you can do, but you have to know a lot about it to do it. So I'll teach that to you as we're going through. So anyway, we have this, we know 3 sides idea. We know that's a law of cosines. Let's go ahead and find an angle. I'm going to find, let's call this angle A. I'm going to find angle A. I'm going to find the angle opposite the largest side. Why? For a number of reasons. Number one, if it happens to be 90 degrees, then I can make a lot of my work easier. Number two, because using the law of sines to find the angle opposite the smaller side, the smallest side, guarantees you have an acute angle, and it guarantees you don't have to check 180 minus theta. That's the way I would use law of sines to kind of trick the problem and not have to use law of cosines twice. But again, you need to know that. I'll explain that as we go through right now. So I've labeled this. I said, if that's A, let's call this B and call that C. I have 3 sides. I know I'm finding an angle. So if I want to find angle A, what I'm thinking is I'm going to have cosine of angle A equal to the square of the sides adjacent to it. That's 4 squared and 5 squared. as a sum minus the angle, minus the side opposite to it. So the sides adjacent squared and added minus the side opposite. Okay, so A and opposite over 2 times the product of the adjacent sides. It's 2 times 4 times 5. So we can simplify all that if we want to. We can also just use our calculator, take cosine inverse, and plug it in at one time. And we're going to get about 125.1 degrees. Now, what about the other angles? So all we've done really is said, maybe not a right triangle, don't know, can't really use anything with it because I'm not sure. We know 3 sides with law of cosines, we're finding an angle, so great. Cosine of an angle equals add the squares of the adjacent side, subtract the square of the opposite. Divide by 2 times the product of the adjacent sides, and then take a cosine inverse. And we've done that. We got 125.1 degrees. What are the rest of them? Can you use interior angle sum right now to figure out these 2 angles? No. No, you can't. You need to know at least one other angle, and then you can do that. So what do? You either do law of cosines to find one of these angles, doesn't matter which, then use law of cosines again, or interior angle sum to subtract and figure out what the third one is. Or, I said this, I would do this, you can use law of sines if you found the largest angle. Or the angle opposite the largest side, that would be the largest angle. Why? Because if you have the smallest side of your triangle, it will be opposite an acute angle. So when you take sine of that, there won't be an obtuse option. Why? Because you found the angle opposite the smallest side. It would be an acute angle, would be less than 90 degrees. That means that you have just one option and the 180 minus theta will not apply. So whatever your sine inverse gives you, that's your angle. That's one way to kind of trick this problem and use it to your advantage. So what I would do is I would take sine of 125.1 degrees over 8 equals sine of c over 4. We're going to try that right now. Sine of known angle over known side equals sine of unknown angle over known side. I've completed one fraction. I have this equal to another fraction that I know only one part of. I know 3 things. I can find a fourth. If we multiply by 4 and take a sine inverse, then what we're going to get is c equals four times sine of 125.1 degrees over 8. Now, this is something I told you a little while ago. This is dangerous to do. Why? Because you've already rounded that. And if you're going to use it, which I am right now, I'm using that, probably shouldn't. But if I'm using that rounded number, this is going to be a little bit off. So c is going to equal, really we should have it here too, because we're using an approximation. C is going to equal an angle that is slightly less accurate than you could get with law of cosines. This is maybe a little bit faster, but it is less accurate. If I knew what that angle was exactly, I would for sure use law of sines. So that's kind of the caveat to what I was explaining a little earlier. Would I do law of sines? Yeah, if I was sure about that angle, I knew exactly what it was, because that's a little faster for me. I like dealing with proportions. I'm more comfortable with them than remembering law of cosines, although it's not all that bad. So that's the caveat. So if you want to use law of sines, you need to know one angle, perfect, and then you're finding the angle opposite the smaller side, because sine of this angle, it has to be acute. You don't have 2 options. So we would get 24.1 degrees approximately. So this is about 24.1. Now, let's say that you were actually given an angle, like here. Then law of sines would work just fine as long as you are finding the angle that's opposite your smallest side. So that's kind of the necessary thing. Otherwise, Otherwise, what would we have to do? If we didn't know this was acute, if we didn't know it was the angle across from the smallest side, which has to be an acute angle, then we would have two options here, the angle and 180 minus the angle. You have to go through the process of figuring out which one of those is right. There would be only one, but it's kind of annoying to have to do that. Now, what if you don't like that? What if you don't like the ambiguity of it? You want to use law of cosines? That's totally fine. If we take and find angle C, let's pretend we didn't know it was 24.1, and we want to do law of cosines, we're going to do the same exact thing. And notice that there's no rounded numbers in that. So cosine of angle C equals take the squares of the adjacent sides, the sides next to that, square it. Subtract the side opposite it squared. Over 2 times the product of the adjacent sides. That I might be messing these up a little bit, but it does not matter as long as the concept of it's right. If you're trying to find angle C, we're just going to verify that it's 24.1 right now. If you want to find angle C, then your adjacent sides are 5 and 8. Your opposite side is 4. Square everything, subtract the 4 squared. Divide by 2 times the adjacent sides, and then take a cosine inverse. Now, at first glance, you might be thinking you're getting exactly the same thing, but notice something. This is actually an approximation from here because because you use an approximation. This just happens to be exactly what you get round to the same decimal place as this, but you would be more exact here. You could get exactly what you want to as many decimal places as you want because you did not use any rounded figures. So that's more appropriate if you're going to use something rounded here. If you're not, then law of sines is perfect. You can do it. Just find the angle opposite the smallest side and it works just fine. For us, this is going to be 24.1 degrees approximately once we round, which is what we get by the law of sines. Now, consequently, because we know both of these angles, you can use interior angle sum to figure out this one. You could also use the law of cosines one more time, but it's really up to you. At this point, I'm going to use interior angle sum and say the angle B is 180 degrees minus 24.1 minus 25.1. And we get the angle B is approximately 30.8 degrees by the interior angle sum. Man, I hope I'm making this make sense. I hope you're seeing how the law of cosines, it could give you something a little bit more exact if you're using an approximation. I hope you're also seeing, though, that you can use law of sines here. It is okay, but you must use law of cosines to figure out your first angle. Or with the side angle side, you must use your law of cosines to figure out your other side. That gives you the ability to use law of sines later or continue with law of cosines. Either one is fine. As long as you're remembering that rounded numbers really decrease your accuracy, so avoid using them if at all possible. So maybe on this one, if you had the choice, I'd use law of cosines because it is a little bit more exact in its essence. So let's come back. I'm going to do one more example with you. We'll give a real life example or at least an application, and then we'll be done. Okay, last one before an application. We got this triangle. It's clearly not a right triangle, so we can't use any sort of things like Pythagorean Theorem to find that missing side, even though we might want to. Can't do it. Can't use right triangle trigonometry. So what are we left with? Well, we could be trying to use interior angle sum if we note another angle. We certainly could do that. We can't use Pythagorean Theorem, so we're left with law of sines or law of cosines. Think through it. Don't just do law of cosines because we're in the section or the video or whatever you're doing. Think about what we're really asking. So what would really work? Could you even set up a law of sines and make it make sense? Law of sines requires you to know an angle and one side opposite to it in order to even use it. So here's an angle, I don't know that side. Here's a side, I don't know the angle. Here's a side, I don't know that angle. Law of sines is done. Like, you cannot use that. With side, 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 it had no angles, so you cannot use that. That means we rely on law of cosines. Law of cosines says that for a side, an angle, and a side, or two sides and an angle between them, we can solve it. And so let's start labeling some things. Again, if you like the formulas, then you can label this with letters like everywhere. You could do that. Say this is maybe A, and then little a. If this is B, then this would be lowercase b. If this is c, then this is lowercase letter c. That would be fine if you're the type of person who likes to label things like that. That's okay. I like to label. I'm more of a concept guy when it comes to formulas, though. So when I think about the formula, what I'm thinking is, with my side angle side, what could I even find right now? Could I find an angle right now? Really think through this. In order to find an angle, you need to know the adjacent sides. That's the only way that our formulas actually work. So if I want to find angle A, I would have to know this side, and I don't. If I wanted to find angle C, I would have to know this side, and I don't. Why? Because in finding your angles, you have to know all three sides. You'd have to know all of your sides for the a squared plus the b squared minus the c squared over 2 times ab. You have to know all of them. And so I don't know all of my sides. So I can't find any of my angles. I have to find a side first, this last remaining side. So I'm going to do that. I'm going to find side B. How does it work? Finding out a side says, think Pythagorean Theorem. If I'm finding out that side, I'm going to take my other two sides and square them, subtract 2 times the product of those sides, times cosine of the angle between them, which consequently is the opposite angle to that side. So finding that side says, add these two sides, square them. Well, add the squares of the sides, I should say. Subtract 2 times those two sides and cosine of the angle between, which is the opposite angle to the side you want to find. Now we're going to plug in some numbers. So b squared is, well, let's see, 3 squared, 2 squared, minus 2 times 3, times cosine of 110 degrees. If we really wanted to be fancy, take a square root of the whole thing, do it all at one time on your calculator. So I just happen to have simplified it 9 for 12 cosine 110. You don't have to. You can just take a square root right from here, put the whole thing in, as long as you use your parentheses appropriately. B is about 4.14 units. That's great. Okay, so now what do we do? You have some options on what you want to do. You can either use law of cosines again, or you can use law of sines. Which should you do? It really depends on what you're given. And it depends on what you're going to find. If you are given the largest angle and you found the largest side, which you have, then if you want to use law of sines, use it to find the angle that's opposite the smallest side. Here's why, for the last time, that with your law of sines, you remember that you have two options, an angle and 180 minus an angle. If you know that you are an angle opposite the smallest side, and that's what you're finding, that will be an acute angle. It will be less than 90, so you don't have to worry about this other one. 180 minus your angle is going to be obtuse. You don't have to worry about that. You know you're acute, so it's 0 to 90 degrees. That's an acute angle. So if that's the case, then you know for sure that that's acute. There's only one case there, and you can do a law of sines. So sine of c over 2 equals sine of, well, there's only one other complete fraction you have. But notice, you are using a rounded number. Now, what about using law of cosines to find angle A? You'd still be using a rounded number. So no matter what, unless you plug in this entire piece for either formula, you're going to be using something rounded in later math. Not the best option, but it is really typically what we do here. So I can show you both of them. I'll show you law of sines, and then I'll show you law of cosines. So law of sines says, you know one complete fraction. You know an angle and a side opposite to it. And I'm going to find the angle that's opposite my smallest side. I know it's acute. That gives me this non-two options idea. I would cross multiply, or I can just multiply both sides by 2 and take an inverse, sine inverse of both sides. So C is sine inverse, imagine this, multiply both sides by 2. You would get 2 sine 110 over 4.14. And then you would take a sine inverse of both sides. That's what I would plug in my calculator. I wouldn't write down little numbers or anything, plug the whole thing in. I got like 26.997, and I rounded it to 27. Please do this. Make everyone happy when you do this, by the way. When you round something, if you round to 27, but you've rounded to get there, put 27.0 to show that, like this, put 27.0 so that it shows you rounded to get there. If you just put 27 without the 0.0, even though the 0.0 doesn't mean anything numerically, it means something rounding wise. This will show people you rounded to get there. If you put exactly 27 without the decimal 0.0, it seems like that's a whole number. It seems like that was an exact answer, so don't do that. That's why you put the 0.0, even though 27 would be counted as the same thing. Now, that's law of sines. Law of cosines would say, hey, if you want to find angle C, here's how we do it. We take cosine of C, square the sides adjacent to it and add them. Subtract the side opposite to it squared. Divide by 2 times the product of the adjacent sides to whatever angle you're finding. Exactly that. Then we're going to take cosine inverse. Okay, I want you to know that I have a slight mistake on the board right now. This and this are technically still approximations because I've used an approximation in it. I know I'm reiterating myself a lot, but it's very important that you understand something we get out of using an approximation is also an approximation. It can't automatically become exact somehow. So those really should all be approximations. And what I got out of that was 27.0 degrees if I rounded. But I wonder if you noticed something. If you did both of these, this was like 26.99 something. This was 26.9 and a different something. It was slightly different. So I think 26.96, but it was slightly different. That is because we used an approximation when we did our math. So cosine and sine will take that approximation and it will deal differently with the error in that. So rounded wise, it usually works out as long as you're not really super rounding that number. It's typically pretty fine, but I do want to point it out to you. So which way is better? If you're rounding, it doesn't make much of a difference. If you're looking to be as exact as possible, don't use a rounded number. If you didn't use a rounded number here and you use this exact thing, this expression in both of your equations, they would come out exactly the same. So I hope that's made sense. I hope that you've seen that you really do need to use law of cosines to solve for that missing side. After that, you have options. You can do law of sines, you can do law of cosines. Law of cosines is preferred for 2 reasons. Number 1, sometimes it lets you not use rounded numbers. Law of sines will not do that if you're working on this type of triangle. Secondly, is that law of cosines doesn't make you use the 2 options like law of sines does. The only way around that is to do what I've shown you and find the angle opposite the shortest side with law of sines. That would avoid your 2 options because you know you're an acute angle. After this, because you know that angle C is about 27.0 degrees, you can use interior angle sum, that's fine. You could use law of sines if you wanted to, that'd be fine. You could use law of cosines again to find angle A, that's also fine. I'm going to use interior angle sum At this point, it's not going to compound any more errors. We already have that error built in, so it wouldn't compound that. And so we would get angle A is 180 minus 110 minus 27.0. And finally, angle A is approximately 43.0 degrees. I hope this made sense. We're going to come back and do one real-life example and see if we can put law of cosines to good work. Okay, last example. So let's pretend you are flying. You're flying from city A to city B. I've never visited city B, but I hear it's wonderful this time of year. City A, whatever. And you're chugging along. You see a little readout, and you're going about 220 miles an hour. And it takes 330 miles to get from city A to fly from city A to city B. And after 15 minutes, your pilot discovers, oh man, I've been going 10 degrees off course. Maybe he didn't account for a crosswind or something. And he's been going off course a little bit. So there's a couple questions. Firstly, what course correction does he have to make at 15 minutes after he left city A? And secondly, how long is it going to take to get there? Or what speed does he have to adjust to get there in a certain amount of time? Both of those questions are things we can answer. So let's start with this. If you have this type of a triangle, is there a way that you do anything right now without knowing more information? Not really. Remember, you need to know 3 things in order to find a fourth. You know only 2. You know an angle and one side. There's nothing in triangles that we can deal with only knowing 2 things. In a right triangle, you automatically know one angle is 90 degrees, so that would be 3 things that you know. So here it's, no, you can't. Have they given other information that we can use? Yeah, it says that you detected an error after flying this way for 15 minutes. If you're going 220 miles an hour for 15 minutes or a quarter of an hour, remember that distance equals rate times time? If distance equals rate times time, then if we travel 220 miles an hour for quarter of an hour, not 15. You didn't go for 15 hours. So make sure your units match here. 15 minutes is 0.25 hours. That would be 55 miles. So we now know a second side of this triangle. Well, that's nice. Now we have a lot more. We have 3 pieces of information. Let's see what it fits. Does this fit a right triangle model? Do we know it's a right triangle? No, and so we really can't use right triangle trigonometry. Can we use law of sines? Law of sines requires you to know an angle and one side opposite it in order to do anything with it. I know an angle, but I don't know the opposite side. I know a side, I don't know the opposite angle. I know a side, I don't know the opposite angle. So law of sines will not work. If you really look at it, there's 2 sides and an angle known between it. That right there is what we can deal with law of cosines. So we're certainly in law of cosines. What do you do with law of cosines? Well, you really can't find an angle until you know all 3 sides. Why? Finding an angle requires you to know the adjacent side. So if I wanted to find this angle, I'd have to know both of these sides. If I wanted to find this angle, I'd have to know both of these sides. I'm missing this side. We have to find that side first. So let's call this side A. If you want to label everything, then this would be angle C, side B. We already have angle A and angle B. Now, our law of cosines is going to tell us what to do. We're trying to solve for this side, so A squared equals, whether you want to use your formula or not, conceptually or just kind of copy it down, either way is really fine. Typically, you're given a formula, but conceptually is a little bit nicer for me because it helps me to memorize things. So if I'm trying to find a side, I think Pythagorean Theorem, I think, okay, A squared equals the sum of the other 2 sides squared, well, the sum of the squares of the other 2 sides. So 330 squared and 55 squared. The formula would tell you B squared plus C squared. Minus 2 times their product of what you just squared and cosine of the angle between them. So cosine of 10 degrees, or the angle opposite the side you want to find. So let's see. here's my side I want to find. I have sum of the squares of these other two sides minus the product of 2 times those sides times cosine of the angle between them, which is also the angle opposite the side I need to find. So if we take a square root of that entire expression and do not round it, A is exactly that. Now that's not very useful if we think, well, I want to know what the distance is and be able to do some distance, rate, time on it. So we're going to approximate that. So we get almost exactly 276 miles, like 276.000 something miles. So we now know that if you're flying for 55 miles, 15 minutes, going 220 miles an hour, then at that point, you are exactly 276 miles away from your destination, this wonderful, glorious city B. Now, what do you do after that? Well, we want to know a couple things. One thing we want to know is, what's this course correction? What angle do you have to adjust to? What that's going to take is us knowing what angle C is and subtracting that angle from 180 degrees to know what adjustment we need to make. So we probably ought to find that angle. Do we care about this angle? No, not so much. Not really at all, actually. So let's use law of cosines. You could certainly use law of sines. So sine of C over 330 equals sine of 10 over 276, now that you know it. But be careful, because this is the longest side of your triangle. I hope you're listening. Because that's the longest side of your triangle, this is going to be your largest angle. This will be an obtuse angle. This will be but in other triangles, you can't guarantee that. Here you can, because it's such a small angle. So law of sines in a lot of cases would not be preferable because you'd have 2 options. So you could certainly do it. I'm going to choose to do law of cosines though, because I want to avoid the 2 options outcome that I'd have to go through. So it's kind of frustrating. So I'm going to do law of cosines and think I want to find angle C. Okay, how does that work? When you're finding an angle, it says you need to know the adjacent sides, square them and add them. That'd be 55 and 276.0 squared each. You need to know the opposite side, which we know, it's 330. And we're going to divide by 2 times the product of the adjacent sides. These 2 should always show up right there. If we take cosine inverse of that entire mess of junk, we're going to get whatever this angle is, which is about 168.0 degrees. Again, we rounded, but it rounded to 0.0, so we're going to show that. That's this angle. Please don't get confused. That's this angle, not this one. So if this is 168.0 degrees, then what's your course correction? Well, if that's 168, a straight angle has 180 degrees. These 2 angles are supplementary. Let's subtract 180 minus 168. Is approximately 12.0 degrees. So this guy's going along at 220 miles an hour. After 15 minutes or 55 miles, he says, oh man, I got to make a correction. What's the distance? The distance to my destination is 276 miles. The course correction that I need to make, judging from my math that we did here, is a 12-degree course correction. Now, how fast does this guy have to go if he wants to make the entire trip? 90 minutes still. An hour and a half, 1.5 hours. Well, here's one thing that students would often do. They'd say, oh, well, if I'm here and I need to go that far, because distance equals rate times time, rate equals distance divided by time. So can't I just take 276 and divide it by 90 minutes or 1.5 hours? No. What? Why? Because you already burned up 15 minutes. Remember, if you want to make your entire trip 1.5 hours, you already boined up. You already boined up. Maybe the city B is Boston. You already burned up 2.25 hours of this. So you only have 1.25 hours left. Hopefully that makes sense to you. Maybe it doesn't. Maybe I can re-explain that a little bit. You discovered after 15 minutes or a quarter of an hour that you are here. You have that far to go. If you're traveling 220 miles an hour and you want to make your entire trip 90 minutes, that is, you're here, you only have 75 minutes left to get here. So this distance divided by 75 minutes or 1.25 hours would give you your speed. So rate equals distance over time. I have that far to go. I have 1.25 hours left to get there. That is 75 minutes because I burned up my first 15 minutes. If you need to get there from A to B in 90 minutes, you're going to have to pick it up a little bit. How far? Or how fast? So 276 divided by 1.25 says you're going to have to increase your speed to 220.8 miles per hour. So increase it just a little bit more and you will make it there right on time. Whole trip altogether after burning 15 minutes going the wrong direction would be still 90 minutes if you increased at this point to 220.8 miles an hour. Hope it's made sense. I hope you're seeing Law of Cosines and I've explained it well enough for you. I hope you see when you can use Law of Sines. A lot of the times, Law of Cosines is a better option, especially if you don't completely understand the two solution idea of Law of Sines. Just stick with Law of Cosines, you'll be absolutely fine. In fact, it helps you check your work. So that's about it for this video. I hope you're enjoying them. Next time, we'll talk about the area of a triangle and how in the world you can use it when you know certain cases, like the Law of Cosines, without having to find a height explicitly. So we'll deal with that next time.